So inheritance is what most used by programming language terminology, but the design terminology oftentimes refers to generalization, meaning that we were able to generalize or separate as a common piece from cat and a dog the piece that we call mammal, and it completely makes sense, and we can prove our concept by describing what mammal is, and then sort of derive cat and dog from this brand new concept and make it useful in software. I typically say, because from practical standpoint, oftentimes, unless you're already an expert user in this particular field, oftentimes you discover the commonality after already starting to work on a dog and a cat, which appear to be completely separate pieces, and then you kind of realize, oh, wait a minute, they have something in common, and I should make a note of it. That's why you need to interview expert users, you need to interview people who have experience, and that's why you have highly paid professionals who actually can detect this commonality at the design stage, so that you don't have to rewrite a lot of code later on when you already written a substantial amount of code. So a little bit more terminology. Again, I said UML, Unified Modeling Language, prefers to name inheritance relationships generalization relationships. At the same time, we sort of recognize, okay, mammal is something like a base idea, very basic idea. It may be so basic that you cannot even create an object of this type, because how it's going to look like, how it's going to be useful to, like, how are we going to present this to a user, which is supposed to visualize it, or maybe try to communicate with it, or try to do something else with it, if we don't even have a specific, concrete, finished concept. So the class may exist, but it may not be even possible to instantiate an object of that particular class. It's called it's called abstract classes. We're going to talk about that. But that's an interesting observation. Next thing is the dog and the cat. So maybe we can create those two, right? And somehow be able to present it to a user. So these two are more concrete. So we say this is more generalized, more abstract, and down here, down in the hierarchy, is more concrete and more defined and less abstract. Okay, all these things. Now notice these arrows. They're always typically the hierarchy. You begin creating the hierarchy, this type of design, by connecting those squares that represent software classes or classes at design time. Connect by arrows, and in UML, the arrows, directional pieces, those connection lines that have arrows in them, always follow the verbal description of what is going on. For example, you can say dog derives from mammal, or dog is a mammal, and that's why the arrow goes up from dog to mammal, okay, and not backwards, right? So it would be maybe possible to say mammal is a common piece of a dog, but in software we don't do it, because mammal actually doesn't know anything about the fact that dog and cat exist. Cat and dog obviously do know perfectly well that they're deriving from mammal, but mammal, by definition, in object-oriented paradigm, the base part, the top part of the hierarchy, has no clue that something else is derived from it. And there's no way for it to anyhow detect that fact, to be aware of it, right? Not by design anyway. And This simplifies this notion that the base class doesn't know about the existence of the derived or parent classes or superclass or subclasses as we define them in Java. Because this makes it possible, very easy, to actually derive like a mouse from, the next day, expand this hierarchy by yet another class. Not a problem. Mammal is not going to complain because it doesn't even know that we're doing it. And cat and dog really kind of exist in their parallel universe. As long as the mammal is there, they don't care. So that is the set of principles to how you can, expand and further, expand your hierarchy, perhaps both, vertical and horizontal. So the terminology, I mean, it's really important to kind of learn the proper terminology and use it. You can tell yourself those words and train yourself to use these words when you write your code or participate in design. I like the word base class a lot because this is like really the foundation from which we derive other things, like the root of our hierarchy in this particular case. But people also use parent class or superclass. So C++ programmers almost exclusively say base class. Java programmers and documentation very often refer to things as superclass. The parent class, I typically do not like to use parent or child because you can actually create dynamic structures such as tree or list, and typically that set of ideas refers to child and parent classes depending on who is pointing to who and who is holding a pointer to who. So I don't think this parent, although you will find it in many places when you read posts and forums and documentation, but in Java, superclass is this guy right here on top, and the base class is what C++ programmers will use almost exclusively. So similarly, the things at the bottom of the hierarchy or somewhere here in the middle will be referred to C++ programmers as derived class, by Java programmers a subclass, right? So get used to this, learn this. You should be able to answer instantly in your head what is the superclass and what is subclass, what is the base class or what is the derived class, if that was the topic discussed. Okay, so we just have to refer to these things as those parts. All right, moving on. So just again a kind of terminology that we need to be aware of. Check the timing on this. All right, so couple more things before the break. Is a relationship. I guess with our discussion here, we could say that, take a look at this. Smart TV is a kind of HD TV with internet access capabilities, internet search capabilities, some extra fluff right here. Right? To some it may be important. To some people may not even know that they're using smart TV in their home and never try to do something about it. Right? So we can relatively safely say that smart TV is an HD TV. Right? Let me actually write it up. Something like this. Smart TV, and I will use like one word to maybe refer to the name of the class. Is an HD TV, right? I can safely save that. It's an interesting thing. Now, if I wanted to use a UML expression instead of saying is a or is an HDTV, what it would be doing is that, remember, it's the derived or subclass refers to a superclass or base class. So therefore, the arrow will be directed this way. That's how the arrow will go. And of course, in UML, it should be like a hollow triangle. So I'm using text to do this type of thinking. So this is like a triangular shape. I can't even see my all right. So here's this triangular shape, and I'm actually beginning to realize what this wait mode is. It probably is trying to wake up my portable drive while it just goes to sleep or something. I don't know. All right, so not much new here, but the recognition of an is a relationship is very important thing to say, because we can say that if we have a circle and a star and a rectangle or square, right? All these are shapes. So when you have a hierarchy, by the way, somewhat unsuccessful demonstration from a textbook where arrows are directed from the base part to the derived pieces, or from superclass to subclasses. So the arrows should really be reversed on this demonstration, but or picture here. But still, this is from the textbook, so I really didn't want to change it, so you can recognize it. So the idea is that a circle is a shape, a star is a shape, a square is a shape, and they all in common, what they have in common is that they all should know how to draw themselves. Okay, so typically when you look at any of these relationships like this one, we can say cat is a mammal, dog is a mammal, right? So you don't say dog is a cat, right? That just doesn't make sense. Or you can say smart cat is a cat. Okay? So again, the direction of these arrows is the direction in which you can say or vocalize this type of relationship.